All right, our enrichment activity that is going to be the first one is something called solving systems of linear equations, and it's going to be using substitution. We'll jump into what does that mean. We'll look at some examples, and then you'll have a chance to try it out for yourself. All right, why did I choose to have you look at this lesson? A big part of it is in 8th grade. A lot of what you're doing is you're joining together this whole idea of algebra and graphing and everything kind of combining together, the visual and then the written part of math. This lesson doesn't specifically talk about graphing per se, but in future ones later on, we'll look at, okay, how do these systems work in a graph setting as well. Okay. Also, it kind of goes with what we're doing, right? Solving equations for certain letters. It's just the next step of this, which you'll look at more in 8th grade. So, what are systems of linear equations? The true definition, a system of linear equations, is just a set of two or more linear equations, right? A linear equation being all the variables only have exponents of 1. And it's two or more that use the same set of variables. So again, our example here could look like this. 2x plus 3 equals 4y. Negative 6y plus x equals negative 5. Okay, in both sets of equations, they're using the same variables, except they kind of look different, right? They're different. Our goal with this is what we're going to do is we're going to learn some methods here in the next couple of lessons about how do I solve for these equations to get a value of x and a value of y that makes both of them true, right? The same x value that I put in the first equation will also make the second equation true as well. And so we'll look at how does that work. The first one we're going to look at is something called substitution. Okay, we've worked with substitution before, so you might recognize some of the elements of it, but with linear systems, it's definitely a step up from what we've done in 7th grade. Alright, so here's our first example. Now, of course, it wouldn't be a Mr. Teal lesson if he didn't make a mistake, so already I've caught myself making a mistake. I had to I had to change one of the equations, so now it should work out nice. Okay, my system of equations is y minus 2x minus 4, and then 7x minus 2y is equal to 5. And what I'm going to do here is I'm going to try and solve this so that I get some value of x equal to something and some value of y equal to something. And with those two values, I can insert them back in, and it should make both of these equations true. Okay, here's what we mean by substitution. What I see right now is that I see my variable y is equal to this expression right here, 2x plus 4, or minus 4. Okay, and what that's going to allow me to do is I'm going to allow to substitute wherever I see a y using this expression here. Now, why would I do that? Well, I'll kind of show you. If I wanted to solve, right, for an x and a y, obviously I'm looking for a number. And in this type of situation, I'm looking at the bottom equation now, there's not going to be a really easy way for me to like move things and divide to where I just get a number. I'm always going to have like an extra variable in the way. So our strategy here is we want to substitute or change one of them so that I'm only working with the same variable. Because if I am working with one variable, I can combine all my like terms and I'll end up at a just the value or a number for an answer. Here's what we're going to do. Since I know that y is equal to this expression, wherever I see a y, I'm going to put in that expression using parentheses. So I see a y right here, and I'm going to put in 2x minus 4. Okay. Now from here, if you notice, we've gotten rid of, in this entire equation, there's no more y's in here, and all I have are x's. This is exactly what we want, because eventually I'm going to be able to solve this for a specific x value that we can then plug in later to make both of these true. So let's simplify that out. 7x, this is going to get distributed in. Again, remember, if there's a minus sign there, we're going to distribute in the minus sign as well. So this is going to be minus 4x. Negative 2 times negative 4 is positive 8. Okay, so there we go. We are distributed there. Combining like terms wise, these two can combine to make 3x plus 8 is equal to 5. And now it's just a two-step equation right here. We're going to subtract 8. 3x is going to be equal to 5 minus 8 is negative 3. To get x by itself, I'm going to divide by 3. And again, I'm going to get x is equal to negative 1. So, I know that in this, if I put in negative 1, I should be able to get the same, or like make both of these equations true. Okay, how do I figure out why? Well, what's nice about this is once I have one of my values, I'm allowed to just take that value, go substitute it in for the other value, or like in one of these equations. And it really doesn't matter. I could plug it in right here, or I could plug it in right here, and we'll get the exact same answer. For this, I'm going to make it a little bit easier on myself. I'm going to substitute it in the first equation. Why? I don't know. It just looks a little bit easier to do. Okay. Simplifying this, 2 times negative 1 is negative 2. Negative 2 minus 4, or going backwards 4, gets us to negative 6. And so my answer becomes this. X is equal to negative 1. Y is equal to negative 6. Now, how do I know if this worked out? Well, we can do a quick little check here and just plug in what I know. I'm going to plug in negative 6 is equal to 2 times negative 1, right? Again, I'm substituting in negative 6 for y, and I'm substituting in negative 1 for my x value. And what I should get is a true statement. Well, negative 6 is equal to negative 2 minus 4. Is it true that negative 6 equals negative 6? Yep. But not only that equation, but our second one will also work out to work the same. I'm going to substitute in there. Then I'm going to substitute in this one. And again, I should be able to set this equal to 5 and end up with this equaling 5. Well, 7 times negative 1 is negative 7. Minus 2 times negative 6 is positive 12. Negative 7 plus positive 12 is 5. And indeed, 5 equals 5. So what we've done is we found a value for each x and y in which both of these equations are equal, which is exactly what we wanted in the first place. Okay. So I'm going to have you try it out now. Okay, there's a couple of try problems here to work through. Again, your goal is to get an x value and a y value to make both of these true using substitution. Okay, knowing what you know, try and substitute it in. Pause the video here, try either one or both of them, and we'll continue in a little bit. All right, here we go. So for my first one, I know I'm solving for x equals and y equals. Well, y is equal to 5x. I know that I can substitute in 5x in my second equation for y. So this is going to be 5x is equal to 2x plus 3. Well, I've got x's on both sides of my equation. So to combine them, I'm just going to kind of subtract this one over because that's going to help me get rid of it. Okay, these cancel. 5x minus 2x is 3x plus 3. Okay, divide by 3, and I get x is equal to positive 1. With that positive 1, I'm going to insert it back into this first one. You can choose either or. I just like putting it back into the easier one of the two. 1 times 5 is 5. My y value should equal 5. Okay. Again, you can plug these in if you would like to check. They work out to be the correct answer there. For the second one, again, looking for something that x can equal and y can equal to make both of them true. I see that I have x equals 5y plus 3. And so what I can do here is I can take any time I see an x, I'm going to plug in that expression there. 2 times 5y plus 3. And then we can write in the rest of this and start trying to solve for distribute in here gives me 10y plus 6 plus 4y is equal to negative 1. Combining these two, I get 14y plus 6 is equal to negative 1. I have to subtract 6. This gives me 14y is equal to negative 7. Dividing by 14 will give me y is equal to negative 1 half. Okay, negative 1 half. All right, using that, I should be able to just plug in negative 1 half into that first one. Again, you can choose either or. I'm going to make it easy on myself. Okay, when I plug that in, I should get this. X is now going to be equal to negative 5 over 2. We're going to add 3 over 1 to that. 3 over 1 can also change into 6 over 2, which negative 5 plus 6 is 1. And so I get also x is equal to 1 half, but this time it's going to be positive. You can certainly go in and check that out. It should work out to be the same. In fact, for my check, I'm going to put in the second one. 2 times 1 half plus 4 times negative 1 half should be equal to negative 1. Well, half of 2 is 1. Half of 4 is 2, but it's negative. Is it true that that is equal to negative 1? You bet it is. So there we go. My answers are there. Okay. So what happens when we don't just necessarily have this x is equal to expression or y is equal to expression? Right? It's been really easy to substitute because I've been given it right away. In this example, though, as you can see, there isn't exactly like x is equal to this or y is equal to that. And so what we have here is we actually have a couple of options that we can do in order to try this out. Okay? So I'm going to show you 2 different ways to try and solve this. Each way is going to work out to be the same. For the first one, if you can recognize some part of one of the equations is equal to, in the other equation, an expression, then we can take this entire thing that matches and substitute in the expression that matches it. Now, why do I sometimes avoid this one? Because we have to substitute in for more than just the variable, and it looks a little weird, right? So in my first equation here, I see 2x plus 3y is equal to negative 3. And in my second one, I know that 2x itself is equal to y plus 5. So what I can do is I can take this entire 2x here and substitute in y plus 5 because I know that 2x in the other equation was equal to y plus 5. Bringing down the rest of it looks like this. Okay, what can I combine? Well, I can get rid of the parentheses because I'm just adding at this point. Y plus 3y is equal to 4y plus 5 is equal to negative 3. Subtract 5 on both sides gives me 4y equals negative 8. Dividing by 4 results in y equaling negative 2. Okay, so y is equal to negative 2. Now I got to figure out what x is equal to. Well, if we, let's see, we can plug this really into wherever we want. I'm going to go plug it into this first equation that I see right now, in which I have 2x plus 3, and there's my y. So I'm going to plug in negative 2, and that should equal negative 3. I'm just going to go like this really quick. Okay, 2x plus, in this case it's going to be negative 6. I'm just going to go minus 6 equals negative 3. I'm going to add 6 to both sides, and I get 2x is equal to positive 3. Dividing by 2 on both sides, and I get x is equal to 1. And How could I check this? Well, let's put both of them in one of the equations. It should work out. 2 times 1, 1.5 should be equal to -2 plus 5. I'm just substituting it in that second equation. Well, 2 times 1.5 or 2 times 3 halves is 3. -2 plus +5 is indeed 3. We have ourselves a solution set. Now again, why do I recommend it against that? Because we don't always get this nice and easy, oh, well, 2x itself is equal to an expression, so we can just substitute it in for this entire thing. Sometimes we have to go a little bit of an extra step and try and solve this equation for one of them. And this is where it gets a hair bit tricky because of the fact that when I start dividing by things, it can get a little messy. Here's what I mean. Let's take the bottom equation for starts, right? Typically, prior, we had x is equal to this, okay? In this one, why don't we try and solve this for y? Well, the only step I need to do here is to subtract 5 from both sides. By subtracting by 5, I'm actually left with 2x minus 5 is equal to y. So what I've done is I've changed this equation into 2x minus 5 equals y. It's the same exact thing. I just showed you it. But now what we've done is by this one little switch, we've gotten it back to where I can simply find wherever my y is in my other equation and plug in what I know, that it's 2x minus 5. So let's do that. 2x plus 3, I know that y is equal to 2x minus 5 is equal to -3. Substituting in here, I get 2x plus 6x minus 15 is equal to -3. 2x and 6x make 8x minus 15 is equal to -3. I'm going to add 15, and I get 8x is equal to +12. Divide by 8, divide by 8, and we get x is equal to, well, this can simplify to 3 over 2, which is also 1.5. Would you look at that? 1.5 matches exactly how we did it on the other side. Okay, since we know that, again, from here it's basically the exact same thing. I can put it into whatever one I want. I'm actually going to put it into this new equation I just made and say that, hey, 2 times 3 halves, or 1.5, minus 5 is going to be equal to y. Well, 2 times 3 halves is 3. 3 minus 5 is equal to y. 3 minus 5 is indeed -2. We have another match there. Okay. So again, a couple of different ways. If you can find something that exists in the other one and I know that it's equal to something, then we can certainly take that and substitute in what do I know it's equal to. Or the second one, which most of the time you actually end up doing, is solving one of your equations for a variable. So in this case, the easiest one was just to subtract by 5 and getting y by itself, and then going through the normal substituting process. So here's your try it problem for that. As you can see, right, there's not exactly x is equal to this, y is equal to this. Okay, so you're going to have to do a little bit of something else. Try this out on your own, and we'll reconvene. Alright, if you tried this out and you did it the way where you recognized, hey, I see 2y, I see 2y, you still would have to try and solve for it. So to make it easier, I'm actually going to solve this equation for x here. Okay, so solving this for x is going to look like this. Okay, I need to subtract 2y away, giving me negative x is equal to negative 2y minus 3. And then since I have this negative here, I can divide by negative 1, which really all it does is it just changes all of my signs to the opposite. Okay, so what I've done is I've just changed this into x is equal to 2y plus 3. And now from here, I'm going to go and use that as my substitution into this x right here. Okay, so I have 2y plus 3 plus 2y is equal to 1. Distributing in, I get 4y plus 6 plus 2y is equal to 1. 4y and 2y make 6y plus 6 is equal to 1. Minus by 6, I get 6y is equal to negative 5. Dividing by 6 gives me y is equal to negative 5, 6. So I have what my y value needs to be equal to here. There's my x value there. I'm going to plug in negative 5, 6 back into my equation I solved for. Can I do it into any one of them? Sure thing. Okay, x is now going to be equal to 2 times negative 5 over 6 plus 3. Okay, which this can simplify to, well, that can make 1, that can make 3. This is negative 5 thirds plus 3. Okay. This is 3 over 1, so when I try and add, I'm going to make this negative 5 thirds plus 9 over 3, in which x needs to be equal to positive 4 thirds or 1 and 1/3. I'm just going to say 4 thirds. And there we go. All right, last example here. We are going to go into a couple of different story problems that uses situations, and then we're going to build a system of equations using that situation. So it says this. We're planning for a birthday party. We buy a total of 50 turkey burgers and veggie burgers for $90. Right? There's a total of things being bought for $90. I paid $2 per turkey burger and $1.50 per veggie burger. How many of each burger did you buy? All right, well, let's kind of give each of these some things. I'm going to call turkey burgers T. T for turkey burgers. Now I'm going to call veggie burgers, you probably guessed it, V. Okay, here's what I know. The amount of turkey burgers plus the amount of veggie burgers has to be equal to 50. Right, it says about a total of 50 of them. And right, it's a combination of turkey and veggie burgers. The other thing I know is that I paid $2 per turkey burger. Awesome. 2 times T. Plus the cost, which is $1.50 for every veggie burger, needs to be equal to my total spent, which is $90. So here's my systems of equations. I have two equations, and now that use the same variables, and now I need to figure out how many turkey burgers did I sell, how many veggie burgers did I sell. Well, let's get started. My first equation is obviously probably the easier one to start with. And again, this is one of those situations where I don't have it nice and easy as being, oh, V equals this or T equals this. I kind of have to make it myself. So let's do this. Let's do this, and I'm going to solve this for T. Okay. T plus V is equal to 50. I'm going to subtract away V to get T all by itself. And I get T is equal to 50 minus V. That is my new equation here. T is equal to 50 minus V. Using that, I am going to substitute in for this t right here, 50 minus v. So 2 times 50 minus v plus 150v is going to be equal to 90. I got to do a little bit of distributing first. 2 times 50 is 100. 2 times negative v is minus 2v. Plus $1.50v is equal to 90 still. I can still combine some like terms over here. So this is going to be 100 minus, let's see, 2 minus 1.5, right opposite signs fight. I'm left with 0.50. I'm just going to call it 0.5 v, and that's equal to 90. Okay, solving for v here, I got to subtract by 100 first. These cancel, giving me negative 0.5v is equal to negative 10. To get v by itself, I'm going to divide by negative 0.5, and I get that v is equal to 20. Right, how many halves can fit into 10? Well, there's 2 halves in every hole. If I have 10 holes, that is a total of 20. And again, negative divided by negative is positive. So according to this, I should have sold 20 veggie burgers. Well, if we do this, let's go plug that in back into this equation I made right here so I can solve for t. T is going to be equal to 50 minus 20, or in other words, t is equal to 30. Okay, so how many of each burger did I buy? We bought 30 turkey burgers. And 20 veggie burgers. There we go. How can we check this? Well, clearly it works in this equation right here. 20 plus 30 is 50. I can go through and I can solve this out just to confirm that this does in fact equal 90 bucks, but it should work out to be that way. Okay. 2 times 30 is 60. 1.5 times 20. That is 0, and that's 10. Oop, that's not where it goes. It goes right here. 0, 0, 2, that is 30. Is it true 60 plus 30 is 90? You bet. So there we go. Our answer is 30 turkey burgers and 20 veggie burgers. Alright, here's your try problem. Last one. Can you set up a system of equations and then solve it to figure out how many sweatshirts and hats you have? Again, make your own variables for sweatshirts and one for hat, and then see, can you solve this out? Alright, let's see how you did. So, first things first. I'm going to call this S. I'm going to call this H. And I know that S plus H has to be equal to 25. Because it says I bought a total of 25. Okay, if I pay $8 per sweatshirt, that is 8S. If I pay $2.50 per hat, that is 2.5H. And that total is 172.5. Here's my system of equations. Let's see. I am actually going to start and solve this for S. I need a minus H, giving me that S is just equal to 25 minus H, which kind of makes sense, right? If I buy a total of 25 things and I take away the hats, well, I'll be left with how many sweatshirts I bought. I'm going to take this expression here and I'm going to substitute it in for the S to get 825 minus H plus 2.5H is equal to 17250. 8 times 25, 8 quarters, that's $2, so that's 200. 8 times negative h is negative 8h plus 2.5h is equal to 172.5. Okay, what else can I combine? I can combine negative h and 2.5h. This is going to end up being negative 5.5h. Again, opposite sign subtract. 8 minus 2.5 is 5.5. And I'm left with 200 over here and 172 here, 50 here. Solving this for h, I'm going to subtract by 200 first. Right? Technically, these should flip-flop. And I'm going to do 200 minus 172.5. 200, 172.50. This is 0. There's a lot of borrowing going on. This is 10. I get 50, 7, 2. That's where I'm at. I get 27, 50. If I divide by negative, and this is going to be negative, 5.5. Divided by negative 5.5. Then we're going to have to do a little bit of division here. 5.5 going into 7.5. I'm going to move each of those decimals once, and I've got to think, all right, how many 55s can go into 275? Well, if I had to guess, I'm going to say 4. Why not? We're going to guess 4. That's 0. That is going to be 22. Well, maybe I can fit one more in. Oh, would you look at that? It hits it exactly. So I can fit 5 of them in there exactly, meaning the number of hats I bought is 5. Okay, so my h is equal to 5, and now I just need to figure out how many sweatshirts I bought. Well, let's put h equals 5 back up into here. S is equal to 25 minus, in this case, 5. 25 minus 5 is S is equal to 20, meaning I bought 20 sweatshirts and 5 hats. Yeah. To check, we can just plug that in to here. 8 times 20 plus 2.5 times 5 should give us our 172.50. 8 times 20 is 160. 2.5 times 5, that is 12.5. Does that equal 172.50? It absolutely does. Alright, there's your enrichment lesson about substitution as far as solutions for linear systems of equations. There's a practice sheet for you if you would like, but again, this extension is exactly what you'll be doing in 8th grade. Using and solving equations isn't just solving for one variable now, it's solving for one to use it to solve for the other, and then checking to make sure do both of them match in each case. All right, so have at it.